Okay, let's go. What is the value of a to the power of n minus b to the power of n? We all are familiar with this expression, a to the power of 2 minus b to the power of 2. And we quickly say that this is the difference of two squares, which can be expressed as a minus b into a plus b. But did you know that a to the power of 3 minus b to the power of 3 can also be expressed in this format? It's going to be a minus b into a to the power of 2 plus a b plus b to the power of 2. Let us see if this expression is actually correct by expanding. Let us expand. A times this, I have a to the power of 3. A times this will give me a square b. This times this, I have plus a b squared. Likewise, when I use minus b to multiply, I'm going to get minus a squared b. But let me write it here. Minus a squared b. Minus b times plus ab, I have minus a b squared. Minus b times plus b squared, I will get minus b cubed. And at the end of the day, you will see that this will cancel out this will cancel out this. So I'll be left with a cube minus b cube, just as we have it on the left hand side. Let us try it for a to the power of 4 minus b to the power of 4. And using the same format, I'm going to have a minus b into a. No, I have to reduce this power of a by 1. A raised to the power 3 plus the next, I reduce it by 1 to the power 2, and I introduce b. Initially, here was b to the power of 0. Now I have increased b to the power of 1. So, power of 1. Plus, I will decrease this power by 1, and I increase this power by 1. I will decrease this by 1. It becomes e to the power of 0. E to the power of 0 is 1. And I increase this by 1. Such that raised to the power 4, you have 4 terms in this bracket. 1, 2, 3, 4. Raised to the power 3, you have 3 terms. 1, 2, 3. Raised to the power 2, you have 2 terms. So, let us also verify if this is going to give us the left-hand side when we expand my right-hand side. A times this, I will have a to the power of 4. A times plus a squared b will give me a to the power of 3b. A times this, I have plus a squared b squared. A times b cubed, I'm going to have plus a b cubed. Next, I will use my minus b to multiply. Minus b times a cubed. Instead of writing it here, let me put it here. I'll have minus a cubed b. Minus b times plus a squared b. I will get minus a squared b squared. Minus b times this, I will get minus a b cubed. Minus b times this, I will get minus b to the power of 4. Such that at the end of the day, this will cancel out this will cancel out this will also cancel out this, and I will be left with a to the power of 4 minus b to the power of 4. So let us generalize a situation by expressing this situation. We have a to the power of n minus b to the power of n. What form shall it take? Using the same format, I'm going to have a minus b into The first term in A here, what should it be? Try, put it in the comment. Have you done that? Let's see if you got it correctly. So it's going to be A. All I need to reduce this power by 1. A to the power of n minus 1. Then next, plus, reduce it by a power of 1 further, I will have A to the power of n minus 2, because n minus 1 gives me n minus 2. And I introduce my B. Next, I'll have plus A to the power of, reduce it by 1, n minus 3, increase this by 1, B raised to power 2. And this will continue until I get to B to the power of n. That is plus B to the power of n minus 1. So this becomes the general expression for the difference in the powers of numbers. So it's not just only the difference of two squares, but generally the difference in the powers of numbers. So I want you to put this result in the comment. Thank you.